Hi, this is Andrew. Thanks for joining me. Today we're going to be talking about Etherchannel and how it works both from a redundancy perspective and an increased bandwidth perspective. Etherchannel is hugely valuable, hugely important. It's not that complicated though, so the concepts of it and the configuration of it won't take that long. So let's start by just imagining things from a spanning tree perspective. You have this situation where the orange and orange are together and the blue and blue, and this will create a loop, and that will cause spanning tree to say, hey, we need to shut down that port. So what happens if this device on port 14 is talking to this device up here on port 14, and we'll call that A, PC server, whatever it is. We have a device there that it's talking to, and it is saturating its link. It's using every bit of that gigabit connection that it can. Well, all of that still needs to go over the orange cable, assuming that the blue cable is blocked. So now orange cable is also saturated. That link is also saturated, and we have no more available bandwidth. So if this PC here on 12 is trying to talk to B, we'll call it, there's no bandwidth available. Something needs to slow down. So that is, and we have this extra cable here that's just doing nothing. So what if we were able to keep that from turning off? What if we were able to say, let's use both of those links without having a spanning tree situation that causes a broadcast storm? So what do? We can take this and we can say, on switch 1, turn this into one link. Turn these two cables into one link. And here we're going to turn those two into one link. Now we've doubled it. We have twice as much bandwidth available. We have redundancy there as well. And we don't have to stop at 2. We can go up to 8 matched ports on a Cisco switch. So we can have all 8 of these if you have some high performance devices here that need to go across the link here. So it also creates extra redundancy, and there are really much more advanced things we can be looking at where this becomes beneficial. So let's just not go deeper into how deep this can go. Let's just say that we want to create these bundles together to give us twice as much. Now when this link saturates, when this PC saturates its link, when this one here is saturated going up here, then we don't have to worry about the implications of this one talking to this one, because we have twice as much bandwidth available. And if they're constantly saturating our links, then we need to potentially add more links here. So that's what we're going to look at in this lab. Let's get started with that. Okay, so what I have here is lab 642, which is implement Etherchannel. And we're not going to go through all of it because there's a lot more to it than just Etherchannel, and it's all stuff that is really important and really good to review, but not critical for the purposes of explaining Etherchannel. So what you're going to find out is Etherchannel is pretty simple, and as we go through, most of the lab is doing other stuff. But if you're going to go, this is actually designed to be a physical lab. If you're going to go through the effort of configuring everything, you may as well do the whole process. So first step, let's create the network. I'm going to take a couple of 2960 switches. I'll call it switch 0 and switch 1. In this case, it's 1 and 2. It is so simple that there's no problem keeping track of things. So we can just, I don't have to name anything. So now this is where things get a little bit different. I'm plugging in. Now this is one of those, right here it's very easy to visualize. PCA is plugged into 6 and that on switch 1, and PCB is plugged into 18 on switch 2. If this were a real lab in a real environment, keeping track of which one is going into which device can be a challenge. You can think that you're working on switch 1 and you call it switch 1, and that would be this one, but you have something plugged into 18. So it's always good to verify that things are plugged in where you expect, that you're working on the device you expect. In the physical room, especially when you're going back and forth, it's very easy to mix things up. I've done it troubleshooting a lot where people don't plug the right things into the right place, and they wind up with situations where it's not working just because they mixed up two things. And I go in and I swap 6 to 18 and 18 to 6, and it works. In this environment, very easy to see how everything plugs in because it's all right here. So this is our whole environment. Let's get it up out of the way a little bit. Now, when you look at the objectives, we did part 1, build network, maybe not basic device settings. We're not going to worry about VLANs or trunking or anything. Really implement and verify an Ether channel between switches is the critical part that we're covering right now. So, what do we want to do? We want, let's throw some IP addresses in here before I get started. 192.168.110, and on PC1 we'll make it 192.168.111. So this one's 10, that one's 11. Now what do we need to do? We need to go in and configure the switches. And you might think that it's cheating to go directly to command line, but it's a tiny bit quicker, and that's worth it in this situation. So we are on the left switch 0, whatever you want to call it. And what do they say? Create an LACP-based Ether channel using F0, F01, F02, group number 1, with both switches actively negotiating the Ether channel protocol. Use the interface range command to reduce the number of commands required. So, let's go configure terminal and int range. Now, if you're not comfortable using the interface range command, it is really useful, really important. You just type in the first port you're using and the last port you're using, in this case just 2. And now we're configuring both of them at the same time. And we're saying go into channel group 1 mode active, and let's get to the other side and I'll show you what that active means. So I go here, I'll go to this command line, and configure terminal, and int range is F01 to 2, and I want channel group 1 mode. And if I do a question mark here, what did I do with active? I said enable LACP unconditionally. I could also do auto, I could do desirable on, passive. There's a whole chart of things that define how that connection is going to get created. And I don't want to worry about all of that whole chart of things. I just want to set it for the thing I want to use. In most cases, setting it consistently for the thing you want to use is the best idea. So in this case, I want active, because that's what I said on the other side. That ensures that it's LACP on both sides. And now I can wait and watch. And what I should see if I do show Ether channel summary is I'll see what's configured. And I have group 1, port channel is PO1 LACP, fast Ethernet 01, 02, and they are coming up at the moment. So now let's see if I can actually access the devices. I go to command prompt and I do ping 192.168.1.10 because this one is 11, and I'm getting a reply. So I'm going across this Ether channel, the Ether channel link between the two switches, and it really is that simple most of the time. So that is the Ether channel portion of Lab 642. That's all I have for you today. Thanks for joining me.